All right, we're here with our rock star to be talking about converting fractions to decimals, okay? And we're also going to learn a little bit about rational and irrational numbers, okay? Ready to go?
Yeah.
Okay, so let's talk about first what fractions and division are and how they're related to each other. Really, 3/5 is the same as 3 divided by 5. A fraction is just a different way of writing division, okay?
Okay.
All right, so if we wanted to understand what 3/5 was as a decimal, we could set up a division problem, right?
Yeah.
Okay, so let's go ahead and set this up, and I put a lot of zeros here just in case we need them, okay? Okay, so go ahead and tell me, what should I write here? Can 5 go into 3?
No.
So I'm going to write a 0 up there. And then I'm going to very importantly bring up that decimal point, okay? So now we can say, can 5 go into 30?
Yes.
How many times?
6.
Okay, so I'm going to write the 6 up there. And now what should I write next?
A 30 under the
30 underneath, good. And then
Yeah.
what should I do next?
Subtract.
Okay, subtract the 30 there, and what would I get? A
0.
remainder of 0. So then we can go ahead and we're going to write our answer up here because we got our remainder of 0, and it's 0.6. Okay? But just for fun, let's go ahead and bring down another 0 like we were keeping going, okay?
Okay.
Okay, so then we have another 0 there, and then 5 goes into 0 how many times?
0 times.
0 times. Okay, then we'll do 5 times 0 is what?
0.
0. Subtract 0 from 0 is what?
0.
0. Okay, let's bring down another 0. 5 goes into that 0 how many times?
0.
0 times, and then 5 times 0 is what?
0.
0. Do you feel like going and doing this forever?
Yeah.
You do? Well, let's not actually do it forever, because if we did, those zeros could take up this whole page and the entire universe, right?
Yeah.
Yeah, so really what we have here is a repeating decimal. We don't write out the repeating decimal because it's 0 that's repeating.
Yeah.
But if we did write it out, this is how we would write it. We would write a line over the part that repeats. Okay?
Okay.
When it's 0, we don't do that. So our actual answer that we'll put a circle around is this one over here.
Yeah.
But you should know that even an answer that stops like this is actually a repeating decimal of 0.
Okay.
Okay? Now let's look at a repeating decimal that's not 0. Okay, we'll do a problem here, 3/11. Okay, what division problem is that the same as?
11 or 3 divided by 11.
Perfect, 3 divided by 11, so we'll set this up. Okay, so let's go ahead and start here. What do I write?
0 above the 3.
0 above the 3, and I'll put the decimal place in there. Okay, now what do I write? How many times does 11 go into 30?
2.
2 times. Okay, what's 2 times 11?
22.
22. Now what do I do?
Subtract
And what do I get?
8.
8. Good. Okay, now what do I do?
Bring down the 0.
Bring down the 0. So how many times does 11 go into 80?
7 times.
7 times. And what's 7 times 11?
77.
77. Good. Now what do I do?
Now you subtract again.
Subtract again. What do I get?
3.
3. And then what do I do?
Bring down 0.
Bring down the 0. Now at this point you might say, whoa, 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 whoa. How many times does 11 go to 30? I already answered that question right up here. So you might start getting a hint that like, is this going to repeat?
Yeah.
So what is, how many times does 11 go into 30?
2 times.
2 times. And what's 2 times 11?
22.
22. We've already been through this. Now we subtract 22. What do we get?
8. Sorry.
8 again, just like we did up here, right?
Yeah.
And then we bring down the 0, and then we say to ourselves, how many times does 11 go into 80?
7.
7 times. And then we write down here 7 times 11, which is...
77.
Do you feel like doing this forever until the end of
No.
time in the universe? Okay. So instead of keeping going, we can write it up here, and we're going to write it in this really special way, 0.27, and we put the line over the whole part that repeats.
Okay.
So that's the same as writing 0.272727 forever. Okay? So here we say that when we have fractions and when we divide, it actually turns into a repeating decimal. Sometimes that decimal is a 0. Okay? Now, what if there are some numbers where there's no repeating? Fractions will always repeat, but there's a few that don't. So let me just show you what those are. Pi is one of those numbers. You might have used pi when finding like the area of a circle or something like that. It's a super cool number that exists in nature. It's 3.14159 ... It goes on forever as a decimal and never repeats. Doesn't repeat the 0, doesn't repeat any other pattern. Okay, there's also Some numbers like the square root of 2 also go on forever. That's what the dot, dot, dot means, never repeats. And we have a name for these things, and I've put a special color in the name here. They're irrational numbers. The ir means not, and the ratio, see that word ratio in there?
Yeah.
Ratio is just a fraction, right? You probably have studied ratios. So these are numbers that are not fractions. They can't be represented by a fraction. Okay, and that's the first definition here. They can't be represented by a fraction, so we call them not fractional or irrational. And the other thing that we know about this is the decimal goes on forever without repeating. These numbers over here are different. They are rational numbers. That means they kind of can be represented by a ratio or a fraction, and the decimal will repeat, and sometimes we don't write it because the repeating decimal is 0. Make sense?
Yeah.
Good job.